one thing that will be helpful to understand is some of the basic operations that we can do with binary numbers. So we'll talk about in this video addition, subtraction, as well as multiplication by 2 and division by 2 through way of arithmetic shifting. So the idea of addition and subtraction is pretty straightforward, especially if you have exposure to, like decimal-based addition and subtraction. Basically, the idea is that if I were to pick two binary numbers, say, let's do something like this, and we'll add it to something like this, right? And just to keep things simple, I'll show you that these are the decimal values. This one is 158, and this one right here is 45. And suppose I wanted to add to these two numbers together, right? The main idea here is that I just add row by row, and I have to carry anytime that there's something that's bigger than what can be contained in a single digit or bit. So for example, 0 and 1 would make 1, 1 and 0 would make 1. If we add 1 and 1 together, that would make 2 normally, right? Which is 1, 0. So what I do is I put down the rightmost digit, 0, and I carry the 1. 1 plus 1 plus 1 would be 3, which is 1, 1. So I put down the 1 and I carry the 1. This again is going to be the value 2, 1 plus 1, right? So 0, carry the 1. This is 0, carry the 1. This gives us 1, and this gives us 1. The answer here is going to be the value 203, right? So you can see that we could just add the values the same sort of way that we would normally do with our decimal values. And the same sort of idea applies to subtraction as well, right? So if I apply the exact same thing with the numbers that I have, just doing subtraction instead of addition, we have the same sort of principles applying, right? In this case, we may need to borrow numbers, right? So 0 subtracted from 1, we would have to borrow a 1 from here. This becomes 0, this becomes 2. 2 minus 1 is 1. This is 0 minus 0, which is 0. 1 minus 1 is 0, so that's all good. This one becomes 1, 1 minus 0, right? Here we have to borrow. We have to borrow twice, actually. So we have to borrow to get this to be 2. But also, this is 0, so it has to borrow from the thing next to it to become 2. And then we borrow from it for it to become 1. This stays as 2, so this one becomes a 1. This one becomes a 1, this one becomes a 0, and this is our answer. In this case, the answer is 113, which is the result of subtracting our two numbers, 158 and 45, right? So nice and easy, right? There's not really anything too complicated going on here, but there are a few things that we have to be a little bit careful of. The first thing with addition and subtraction is taking a look at the size of our number versus the size of our result. In this example here, if we were to carry a digit beyond 8 bits, in this case we have 8 bits that we're working with, this could potentially be a problem because if the data size that we're working with is a single byte or 8 bits, it would mean that the carry is too large, so it can't be contained within those 8 bits. We could call this an overflow or a carry. We'll talk more about the semantics in between those and which one we're going to consider it as when we get into more of assembly instructions, as it varies a little bit by processor and style, right? Similarly, with our subtraction, if we were to borrow from a bit that didn't exist, so if I got to the very end, this 8th bit, and I had to borrow from something next to it, that could also be a problem, right? Because that value technically isn't existing, right? Again, similarly, we would call this some sort of overflow or carry, depending on what we want to classify it as. And using this sort of idea, we would have to account for that, right? So basically, if we see an addition where the result is too big to contain inside of, the 8 bits that we have, we may need to log that and indicate it, right? Otherwise, you can have situations like, if you have like a C variable that's defined as a byte and you make it too big, it can overflow back to 0, right? Like 255, and then we add a bunch to it, we could get back to like 3 right after addition. It overflows and loops back to where it started, right? So these sorts of situations we want to try to keep track of and avoid. So we'll see that sort of idea as we go through and build out like circuitry and instruction sets, right? So these are two things just to be aware of. Other than that, addition and subtraction, pretty straightforward operations, right? The final sort of idea that we're going to talk about is multiply by 2 and divide by 2, which are also fairly simple instructions. Suppose you have the following binary number, 0, 1, 1, 0, which would be equal to 6 in decimal, right? 4 and 2 make 6. If I want to multiply this value by 2, what I can do is an arithmetic shift. What that means is I add a 0 to the right-hand side here, and I move everything over by 1 position. So if I were to shift everything over 1 position in this number here, basically this 1 would take the place of this 0, this 1 takes the place of where the 1 used to be, the 0 becomes here, then we put in a new 0 in to replace this old 0 here. That gives us 1, 1, 0, 0. When we take a look at this is 8 plus 4, which is 12. Do you see how that just multiplied our number by 2, right? So this is the idea. If we shift to the left, we end up multiplying by 2, right? Similarly, we can divide by 2 using a similar sort of process. Just to note, this is integer division, right? So we're dividing by 2 without any sort of decimal component. So if I start with 6, I could do the opposite. I could shift to the right by 1. If I do that, this 1 replaces this 0, the 1 replaces the 1 that used to be there, this 0 replaces this 1, and then we have a sort of imaginary 0 that we add in that becomes the new 0 that we have just replaced, right? So that gives us 0, 0, 1, 1, which gives us the value of 3. And you can see that this is very clearly just a division by 2. So if we shift to the right, what we do is we divide by 2. These are really the core operations that I want you to understand as we're starting to get into more complications with binary numbers. So these are different kinds of operations that we may want to be able to do just as a basis of binary operations. As we continue forward, we'll see that there are other operations that we may want to do that are more complex, right? We may want to multiply by something that isn't 2, right? In that case, we have to do something a bit more complicated. Same with division by something that isn't 2. Those situations become a bit more complex. As we continue to build up our understanding, we'll see how those operations are generally handled inside of our processors. But this gives you a nice little baseline to work with for binary operations. So thanks so much for watching this video, and I'll see you in the next one.